So today's focus is on integration by partial fractions, and we know that there's differentiation and integration. So today's focus is actually to look at one way of reversing a differentiated equation. Okay, so this one is by use of partial fractions, and we've already done partial fractions, and I'm confident that you are good. So in my preamble, I think I want to say that for you to understand this, you need to have a full understanding of what partial fractions is, and then breaking them into different components. Otherwise, this would be more like a sheer waste of time. I'll be trying to quickly remind you of a few partial fractions concepts, but my main focus is not on the partial fractions. I just want us to be able to break a given expression into components and then use integration rules to look at how we can differentiate that. So now the first question here, we are told to say find the integral of x plus 3 over x minus 2 in brackets, x plus 1 in brackets. So now if you look at this integral here, it's very difficult to differentiate, to integrate this, even if we know all the rules on integration. So first of all is to be able to break down this expression into components that are smaller. Then maybe from there we can pick the integration rule that we can use. So the first thing is to break this into partial fractions. So we know that from what we did on partial fractions, since we've got x plus 3 over x minus 2, x plus 3 over x minus 2, and then x plus 1. Now, if you look at this, there are no repeating denominators here. And by partial fractions, we said when the denominators are not repeating, this is the rule. You break it down like that, over b over the second denominator or expression. So this is the rule of partial fractions. And we just need to cross multiply and equate the top that we are going to get with the top or the numerator into there. So this would imply that x plus 3, okay, which is on the left hand side, would be equal to a, then multiplying x plus 1 plus b multiplying x minus 2. So this is what we're dealing with here. Now our duty is to be able to find the a and the b. Okay, now what we need to do here is very simple. We need to look for values of x, okay, that would either make a component disappear and vice versa. So here you can see I've got x minus 2 here. I want to make b disappear or eliminate b in mathematical terms. So I have to say let x be equal to 2. Now when x is equal to 2, this equation is going to become x, okay? So what we're gonna do here, this equation is going to become 2 plus 3, because where there's x here, I'm going to put 2, equals, then there's x here, I'm going to put 2 to mean 2 plus 1, 3. 3 times a to be equal to 3a. And then here, there is a 2 minus 2, which is 0. 0 times b, so that would become just 0. So this means I'm going to get 3a equals to 5. And if I divide by 3, I divide by 3, I get a being equal to 5 over 3. So I'm going to keep this and then see if I can find another x, another value of x to help me find b. Okay, so that way we just need to find the x value that would make this here component be 0. So if you look at it, what we have is x plus 1. So we need to try and make x, we must make x negative 1 so that negative 1 plus 1 can be 0. So we are going to say let x be equal to negative 1. If we do that, it implies that this is going to become negative 1 plus 3 equals a negative 1 plus 1, because we are substituting negative 1 where there is x, plus b being equal to negative 1 minus 2. If we do this, this would actually become 2 being equal to, this is going to go to 0 because it will be 0 times a, negative 3 here times b to give me negative 3b. And then I can divide by negative 3, divide by negative 3, implying that b is equal to negative 2 over 3. So once we do this, then we can integrate. Okay, so what we are going to do, because we know from the beginning that this was equal to a over x minus 2 plus b, where there is a, I'm going to put 5 over 3. So the integral now would become the integral of x plus 3 over x minus 2 x plus 1 dx would be the same as the integral of, open brackets. Now where there is a, I'm going to put that, and we should be comfortable enough to know that this would be 5, then this is going to become 5 over 3 x minus 2, like that, minus, since b is negative 2, negative 2 over 3, then x plus 1, like that, then dx. Okay, so now here we are going to just see how we can work with this, and I'm going to give you a rule that works. There is a rule that goes, if you've got a over some constant bx plus c for some reason, and you're doing integral of that, this is the same as a ln modulus of bx plus c, and then plus some constant k. Okay, now if you look at this, this can be our a, that can be a function that we have there. So we are simply doing a direct application of this rule, and I ask that we get familiar with these rules, because in most cases we just need to apply them. So this means now what we have here is 5 over 3 ln modulus of x minus 2 minus 2 over 3 ln modulus x plus 1, and then everything plus some constant c. So that's the integral of that. Let us look at the second example. Now in our second example, we've got a repeating denominator here, or a repeating factor, they say. So the rule is, when you have such a scenario, those, if you remember the rules, we say a over x plus b over x minus 1, the first degree factor, plus c, and then we've got x minus 1 squared. So the repeating factor has to keep on increasing until the degree of the power. Okay, so now here what we need to do is to remember that when we want to find what equates the numerator of the given expression, this has to multiply the highest degree factor. So we know that it will be, first we write 3x squared plus 2 equals, if you've forgotten the rules, since this is a repeating factor, if x goes into the highest common denominator of this distribution here, we are just going to have a multiplying the highest degree factor. So this becomes a x minus 2, and then b would be, this guy is going to be b x and then x minus 1, and c, which carries the highest degree factor, is just going to multiply x, since this is already in that, since this x minus 1 is already in x minus 1 squared. Now here, this is the most interesting part of partial fractions. All we just need to do here is to find values of x that will make us find or eliminate other components to find a, b, or c. So already here you can see that if I let x be equal to 0, I'm not going to have the b and the c. So we already say let x be equal to 0, which implies that 3 times 0 squared plus 2 would be equal to a 0 minus 1 squared, so minus 1 squared, and then plus, already if I put 0 here where there is x, this whole thing becomes 0, and that whole thing becomes 0. So it's more like b times 0 plus c times 0. So all of these would be 0. To leave me, 0 times 3 is 0 plus 2. So we've got 2 equals negative 1 squared is 1, implying that a is equal to 2. So we find a being equal to 2. All we are going to do again is to find another value of x that is going to eliminate either c a or b a to find c. Okay, so again you can see actually if I make x be equal to 1, I'm going to have 0 in here to mean this will disappear, and this will also disappear. We shall just find c. So right away we will say let x be equal to 1. So that means we are going to have 3 multiplying 1 squared plus 2 equals, if I put 1 here, I'm going to get a 1 minus 1 squared plus b times 1, then 1 minus 1, which would be 0, plus c times 1. All of these would give me 0. They would go to 0 because that would be 0. To mean this is 3 plus 2 equals c. This would then imply that c is equal to 5. Now we've found c, we've found a. What is just left to be found is b. So in this case now, we can just replace the values of a and c into this equation here. And then we look for any value of c that will just leave b as the only unknown. So I would say x be equal to 2. It's fine. So I'm going to have, we're going to say let x be equal to 2. So we know that this is going to be 3 2 squared plus 2 equals, already a is equal to 2. So we've got 2, then 2 minus 1 squared plus b times 2, since x is equal to 2, then 2 minus 1, and then remember that c is 5 and x is equal to 2, so we've got plus 5 times 2. So here if you look at this, there is only b that is unknown, so we are going to have 2 squared is 4 times 3, that gives us 12, plus that gives us 14. So you've got 14, okay, 14 equal to 2, and then plus 2b plus 10. So here this is just basic algebra, and if you do your math very well, 10 plus 2 is 12, transpose it over, 14 minus 12 is 2, divide by b, so you should confirm that b is actually equal to 1. So at this point we've got b, we've got c, we've got a. All we just need now to do is to replace in the top equation here, where there's a we are going to put 2, where there's b 1, where there's c 5, and then we look for the integrals of all these individual components, which makes it way easier. So that's what we are going to do. So we already know that we are now finding the integral of a, which is 2 over x, plus the integral of b, which is 1 over x minus 1 dx. All these are integrals in terms of x, plus the integral of c is 5 over x minus 2, then squared dx. So this now looks much easier to integrate, and we've got the rules that can help us integrate these bottom ones compared to the top that we were given. So here I'm going to remind you of rules. If you've got integral of 1 over x dx, what we find is equal to ln of x, okay? So now, based on this, we know that this is going to be, so this is going to give us 2 ln of x, okay, plus ln x minus 1, okay, and then plus, we want now to integrate. Now here I want to take you back. This is the same as integral of 5 then x minus 2 to the power of negative 2 dx. And this is the basic integration that we did when we started looking at part 1 of integration in the previous video that was just sent yesterday. We need to add 1 and then divide by negative 1, which is the answer that we get, and then times the derivative of the inside, which is 1, to find the derivative of such. So if you do that, you can actually see that we are going to have negative. So this should be, the integral of this should be, since this negative 1 times 1 is 1, dividing 5, it would be negative 5 over x minus 2, and then plus some general constant c. So this is the integral of the given equation there. So I can actually maybe go up and just write it there, here. So we do not have space, so I can write it nicely here to mean this is just 2 ln modulus of x plus ln modulus of x minus 1 minus 5 over x minus 2 plus some indefinite constant that we may not know is the answer to this question. So what I'm just doing here is, like I said in part 1 of further integration in P3, we need to look at the rules of integration. So thank you very much for your time. We'll keep on looking at other forms of integration in the next videos.